In this video, I want to explore how to find the least common multiple, what we call the LCD. The LCD, right? So when do you need the LCD? You need the LCD when you want to add fractions or subtract fractions. That's when you need the LCD. So take note of that. Addition and subtraction of fractions. Okay. So let's say that you have 9 and you want to find the least common multiple of 9, right? You break it down into the factor tree. So we know that 9 is made up of 3 times 3, right? So when you break it down the factor tree, you want to use the prime factors. And if prime factors are numbers that have only 2 factors, 1 and itself. So we can break that down to 3 times 3, like this. Okay, we can break this down again. So we just have 9 is equal to 3 times 3, right? Then if I have 27, the prime factorization of 27, right? If you break down to factor 3, that's the prime factorization. It's 3, you can start with 3 times 9, which is 27. Then you can break 9 down again into 3 times 3, right? So 27 is made up of 3 times 3 times 3. Those are the prime factors. If you multiply this, you get 27. So that's what we have here. 3 times 3 times 3. That's 27. So if 9 and 27 appear in the denominators of fractions that you're adding or subtracting, you need to find the LCD, right? The least common denominator, right? So what would be the least common denominator for 29, sorry, for 9 and 27? 9 and 27, when you have this in the denominator. Okay, so let's see how to approach that now. So now that you've broken down to the prime factors or the prime factorization of each number, 9 and 27, we want to find the LCD. To get the LCD, choose the highest number of times that the factor appears in each factorization, and then you're going to multiply them. All right, so that's the statement I have here. So let's go back. So 9 times 9 is equal to 3 times 3. The factor 3 appears twice here. What about 27? The factor 3 appears 3 times. 1, 2, 3 here. All right. So as I said, to get a least common denominator, you need to choose the highest number of times it appears. So between 9 and 27, the highest times that 3 appears in the factorized form is 3 times. So we have LCD equal to 3 times 3 times 3, and that gives me the 27, right? So 27 will be the prime factorization and the LCD for 9 and 27. All right, let's try another one here. Let's say that I have 4 and 18 appearing in the denominator, right, of a given fraction. All right, and we want to find the LCD. So let's say that I have something like 1 over 4 plus 1 over 18. Okay. So something like this in the denominator. Okay. What do I do? Again, I'm going to break down 4 and 18 using the prime factorization approach, right? The tree diagram, the tree factor tree. So 4, I can break down to 2 times 2. 18, I can break it down to 2 times 9. I can break 9 down again to 3 times 3, right? So the prime factors here are the numbers I've circled, right? So 4 is equal to 2 times 2, okay? And 18 is 2 times 3 times 3, and that's this, okay? So now, how do I get the LCD? To get the LCD, as I said, you choose the highest number of times each factor appears in each factored expression, all right? And then you multiply them. So if you look at this, the prime factor 2, 2 appears twice here, but it appears once in a factorization of 18. So I'm going to choose the highest number of times appears twice maximum here. So that's what I have here. Okay. Then what about the 3? I have 3 here. 3 times 3. All right. The highest number of times appears. It appears twice here. There's none here. So the maximum is twice. So that's what I have here. So you multiply the number of times, the highest number of times appears in each factored one right here. Okay. So the LCD with 4 and 18 is 2 times 2 times 3 times 3, and that is 36. Okay, so that's how you find the LCD. Okay. All right, let's try another problem. So let's say that I have something like 1/15 plus 1/10 plus maybe 1/20. All right. So we need to find the LCD before we can add this up. All right. So how do I find the LCD here? To find the LCD between 15, 10, and 20, we can start the prime factorization. So 15 is 3 times 5. 10 is 2 times 5. And then 20, we can break it down to 2 times 10. And then we can break down the 10 down to 2 times 5. Right? So these are the prime factors. The circled are the prime factors. So 15 is equal to 3 times 5. 10 is 2 times 5. And 20 is 2 times 2 times 5 right here. Okay. So now let's find out how many the maximum number of times each factor appears. I have 3 is one of the factors. So let's start with the 3. If I look at this, 3 appears once here, and the factor 5 appears once here, right? So 3, that's the maximum number of times that appears is once. So that's one time. Now what about 5? I have 1 here, it appears once here, it appears once here. So the highest number of times appears is once. So it was just 1. So that's once. That's the highest number of times that appears. All right, once. Now what about 2? So let's look at 2. You have 2 here, it appears once here, but it appears twice here. So the highest number of times appears, if we consider all these factored form, is twice. So it appears twice here. So the LCD is 2 times 2 times 3 times 5. That is 60. In other words, 15 can go into 60, 10 can go into 60, 20 can go into 60. The smallest number that each of these can go into, that is the least common denominator. Okay. So with this knowledge, now let's try a question where we're going to add fractions, additional fractions. So let's try this question here. So given 3/4 plus 2/3, how can we add these two numbers? How can we add the two numbers? So what we are looking at is 3/4 plus 2/3. So those are numbers we want to add. So we need the LCD, 4 and 3, right? So break it down. If you break it down, use the factor 3, you realize that the LCD will be 12. So 4 can go into 12, 3 can go into 12, the smallest number that each of them can go into, right? So that's LCD, 12. So try that yourself. Use a factor 3 to try this and see if you can get 12. Now we're going to write each of these fractions with the common denominator, the least common denominator. Okay, so we say that we want to write each of these as equivalent fractions with a denominator of 12, the LCD. So how can we do that? Now, so I'm going to ask myself, how can I get 12 in this denominator, in each of the denominators, right? Or what can I do to each of the numbers in denominator to get 12? Now, to get 12 in the over here, I have to multiply by 3, right, to get 12. So that's 12 here. So what if I multiply the denominator by 3, I have to multiply the numerator also by the same number 3. So 3 times 3, that gives me 9. Right? How can I get 12 in the denominator here? This is 3. I have to multiply 3 by 4 to get 12. Whatever I do at denominator, do the same to the numerator. So I multiply this by 12. 4. So 2 times 4, that gives me 8. All right. So now I have each fraction written with a denominator of 12. Now we can add the numerators. So when you're adding fractions, you add the numerators, right? Not the denominators, not adding, just the numerators. Okay, so I have 9 plus 8, and that gives me 17. 9 plus 8, 17, all right, over the common denominator of 12. In other words, you're looking at 12 parts, right? So you have 9 out of 12 parts, 8 out of 12 parts, and you're adding them. So what do you get? You get 17 out of the 12 parts, right? 17 out of 12 parts. That's what this means, okay? All right, so by this, now it's at 17 over 12. So this is an improper fraction, okay? So we can change this to a mixed number. How do you do that? Okay. So you have to divide 12 into 17, right? So 12 into 17, 12, you get 1, remainder 5, right? So you write the 5 out of 12 parts. So it's one whole number, 5 out of 12 parts, right? So this is how you deal with fractions when you are adding them. Right, let's try another problem. You have 2 over 7 plus 3 over 8. Okay, looking at this now. Okay, so the steps again, to add fractions, you need LCD. Right, so the LCD of 7 and 8 is equal to 56. Then secondly, you're going to write each fraction as equivalent fractions with LCD, with the LCD. Then we'll add the numerator. So these are the steps that I've been talking about that you use for fractions. Okay. So if the LCD is 56, use the factor tree to test yourself if you can get 56. Right. So the 56, how can I write each of these with a denominator of 56? Let's begin 2 over 7. It means I have to multiply the 7 by 8 to get 56. All right. So whatever I do the denominator, do the same to the numerator. So 2 times 8, so I have 16 over 56. 8 times 7 will give 56. So if I multiply this by 7, I have to multiply the numerator also by 7. So I have 21 over 56. All right. Now we can add the numerator, 16 plus 21. That gives me 37 over the common denominator. So we have 37 out of 56 parts. Great. So I hope you know now you feel comfortable writing, finding the LCD and also writing fractions as equivalent fractions before adding them. All right. All right. Test yourself again on this. Add 2 over 5 plus 4 over 9. 2 over 5 plus 4 over 9. All right. So let's see. To add fractions, again, you need LCD. So what's the LCD between 5 and 9? It's going to be 45, right? 45. So write each of them as equivalent fractions with 45 as your denominator. So we know that 5 times 9 will give us 45. So I have to multiply the numerator also by 9. So 2 times 9 is 18. Then multiply 9 by 5 gives us 45. So I have to multiply the numerator also by 5. 4 times 5, that is 20. Okay. Same denominators. Now you can add the numerators. So 18 plus 20, that gives us 38 over 45. Right. Okay. So let's stretch this a little bit and look at fractions, how 3 fractions being added together. The approach is the same approach. So 1 over 3 plus 3 over 5 plus 2 over 7. Okay. Now to add these fractions, we need the LCD. So between 3, 5, and 7, the LCD is 105. Okay, again, try this using the factor tree to see if you can get 105. Okay. So write each denominator with LCD with the LCD. Okay, so it's 3 times 35 will give me 105. All right, so I have to multiply 1 by also by the 35. So that is 35. 5 times 21 will give me 105. All right, so multiply numerator also by 21, so I have 61. And then 7 times 15 will give me 105. Multiply the numerator also by 15, so I have 30. Yeah. Same denominators, now you can add the numerators. 35 plus 61 plus 30, and they have 126 over 105. Okay, right. So we can rewrite this as a mixed number, right? So to write as a mixed number, it means I have to divide 105 into 126. So if you do that, so you have one whole number. So because 105 can go into 126 one time, leaving 21 over 105 as the remainder. So 21 is a remainder. So one whole number 21 over 105. Okay, will be your answer. Great. All right, so let's stretch this a little bit more by looking at addition of mixed numbers. Addition of mixed numbers. That's numbers that have whole numbers and fractions. Okay. So let's say that you want to add 2 1/3 plus 3 1/4. We'll begin by finding the least common denominator between 3 and 4. So these are denominators 3 and 4. So what's the LCD? The LCD again is 12 for this, right? So let's write each of these fractions with denominator of 12. So we ask ourselves, how can I get 12 in the denominator here? So I have to multiply 3 by 4 to get 12. Whatever I do to the denominator, do the same thing to the numerator. So 1 times 4, which is 4. Do the same thing here. How can I get 12 in the denominator? 4 times 3 gives me 12. So whatever I do to the denominator, do the same thing to the numerator. So multiply the numerator also by 3. So I have 3 out of 12. So these are equivalent fractions. Now we can add the numerators or the fractions. 4 plus 3 gives me 7 over the common denominator. Add the whole numbers. 2 plus 3, you get 5 whole number. Okay, so the answer is 5, 7 out of 12 parts. 5, 7, 12. Good. So the same approach, all right? So this is how you approach it using these steps. So find the LCD, write each fraction as equivalent fraction using the LCD. Add the fractions as usual, just as we've done previously, and then add the whole numbers. Okay. So I hope this is helpful to you. Yeah. On the pre-NL exam, there are a lot of fractions, so you have to make sure you are good with working with fractions. All right, let's try another problem. 3 2/3 plus 2 3/4. Add these two up. So LCD 4 and 12. For 3 and 4, the LCD is 12. 3 and 4, LCD is 12. Okay. So equivalent fractions for each fraction. So I need 12 in the denominator. So 3 times 4 is 12. Multiply numerator by 12, by 4. Numerator here by 4. You get 8. So it's 8 out of 12. How do I get 12 here? You have to multiply by 3. So 3 times 4 is 12. Multiply the numerator also by 3. So I'll have 9. So I have 9 out of 12. Same denominators, I can add the numerators. So I have 17 out of 12. Add the whole numbers, I have 5. So I have 5, 17 out of 12. But we can leave 17 out of 12 this way because this is an improper fraction. So I have to convert to a mixed number. So to convert to a mixed number, I have to divide 12 into 17. Remember, you divide in 12 into 17. All right. So if you divide 12 to 17, you have one whole number, leaving 12. And if you subtract, leaving 5 as the remainder. So it's one whole number, right? 5 out of 12. One whole number, 5 out of 12. This is in the mixed form of 17 out of 12. Then we can add this one to the whole number here, the whole number to another whole number. So if we add that up, we get 6. Right, so we have 6 whole numbers, 5 out of 12. Okay. So don't leave your answer as a number in the improper fraction. That's a good way to leave your answer. All right, so same with subtraction. Once you are good at addition, subtraction should be fairly easy. Same approach. Right. So simple problem like 3 over 8 minus 2 over 7. You need the LCD is needed. Again, same steps, write each as a equivalent fraction with the LCD, and then subtract the numerators. Keep the answer over the LCD. All right, so you need 55 in the denominator, that's LCD. So if we multiply 8 by 7, I get 56. 3 times 7, so I multiply the numerator also by 7. So I get 21. So I have 21 over 56. I need 56 here. 7 times 8 is 56. All right, so I'll do the same thing to the numerator. 2 times 8. So I got 16. All right, out of 56. Once the LCDs are you have written as equivalent fractions, subtract the numerators. 21 minus 6, 16. 21 minus 16. So that gives us 5 over the LCD, which is 56. All right, good. Now, what about the situation where you have a mixed number and subtracting? Okay, the steps are the same. Okay, when you're working with the fractions, all right. So find the LCD, write each fraction with the LCD. Then, so let's do the first 2 steps first here, and then I'll talk about this other step here. So if you write the fraction as equivalent fractions at LCD, LCD is 15. So we need to multiply 5 by 3 to get 15 here. Whatever I do here, I multiply this also by the same number 3. So I get 3 out of 5. Fraction 2 over 3, equivalent fraction, LCD of 15. So I have 3 times 5 is 15. Multiply 2 by 5, that is 10. So I have 10 out of 5. Now I'm going to do a subtraction. If I look at this, I have 18. If I look at this, I have 3 minus 10 over here. 3 minus 10. If I do that, I'll get a negative number, negative 17, right? Which is not too good for this problem, because there's a whole number that I can always borrow from. to create a bigger number to use in the subtraction, right? So I have to do that. If there's no number to borrow from, then you can have your answer as a negative. So let's learn how to borrow from the whole number to create a bigger fraction. All right, so I'm going to borrow 1 from the 7. What if I borrow one whole number from the 7? The one whole number that I borrowed is equivalent to taking 15 out of 15 parts. If I have 15 parts and the number divided, let's say 15 parts, right? 15 parts. And I take all the 15 parts, it's still one whole number. So it's 15 out of 15 is 1. 1, right? So I'm going to borrow 1 from the 7, and that is, I have 16 whole numbers left. So the one that I borrow, it's 15 out of 15 parts. So the 15 out of 15, I'm adding those parts to the 3 out of 15 that I have here. So it means that now I have 18 parts out of 15. 18 out of 15 parts. And that's where this comes from. Okay, 18 out of 15 parts. Okay. So I have now a bigger fraction to use to do the subtraction. So I can now do 18 minus 10. And that gives me 8 out of 15. And then subtract the whole number, 6 minus 3. And that gives me 3. So I have 3 out of 3 whole number, 8 out of 15. That's my answer. Okay. So borrowing approach is very helpful, especially it helps to save time when you have questions that involve multiple steps. Okay. So good to learn the borrowing approach. Okay. All right, let's see another problem. Let's apply the same approach here. If I have 5 1/3 minus 2 3/4, all right, I have to begin with the LCD. 3 and 4 LCD is 12. LCD of 12. So let's write the denominator with LCD of 12. 3 times 4 is 12. Multiply numerator also by 4. So it's 4. 1 times 4, that's 4. Same thing here, 3 over 4. Else multiply the numerator by 3 gives me 12 to get the LCD. Right? Multiply the numerator also by 3, so get 9 out of 12. Now let's do a subtraction. 4 minus 9. This is impossible because you're going to get a negative number, right? So we don't want that here because we can borrow from this whole number to create a bigger fraction. So let's see how we can create a bigger fraction. So if I borrow 1 from the 5, I'll have 4 whole numbers left. The one that I borrow is always equivalent to the parts, the LCD. It says 12 out of 12 parts. So I'm borrowing the one whole number is equal to 12 out of 12 parts. All right. So if I add this 12 out of 12 parts to the 4 out of 12 parts, it gives me 16 out of 12 parts, 12 plus 4. Yeah, so that's where this number came from. So now I've created a bigger fraction. So I have 4 whole numbers, 16 out of 12, minus 2, 9 over 12. Okay. Now I can subtract the numerators. So I have 16 minus 9, that gives me 7 out of 12 parts. And then subtract the whole numbers, 4 minus 2, you have 2. So the answer is 2, 7 out of 12 parts. So I hope you're finding this approach easy to use. All right, so you can pause the video and retry the problem yourself, and see if you can get it right. Right, great. So now we've covered addition and subtraction of fractions, the simple problems, and also we have mixed numbers and the borrowing approach, to creating bigger fractions. Try and get used to that approach. Okay. Now let's look at multiplication of fractions. How do you multiply fractions? Okay. Right. I want us to look at a situation where we have a mixed number. So you have 3 1/3 times 4 2/5. To multiply this out, you don't need LCD in multiplication and division of fractions. You don't need LCD. So take note of that. All right. So if I have a mixed number, I have to change to an improper fraction first. So change to an improper fraction. First step, if you have a mixed number. How do you do that? You multiply the denominator by the whole number, so 3 times 3, and then add to 1. So 3 times 3 is 9, 9 plus 1, that gives you 10 over the denominator. Right, same here, 4 times 5 is 20, then add these 2 to it. So it's 22 over 5. Okay, changing to mixed number. So that's the first thing that you do. So once you've done that, then you can reduce to lowest terms. If you are comfortable, I like to reduce to lowest terms because it makes your life easier. So how do I reduce to lowest terms? Okay, I have 5 here. I can cross 5 into itself is 1. 5 into 10 is 2. All right, there's nothing else to reduce. So I can now multiply horizontally. 2 times 22, which is 44, and then 3 times 1, which is 3. And then I change this to a mixed number, okay, by dividing 3 into the 44. And I get 14 whole numbers, 2 out of 3 left. Okay. So remember these steps. All right, so same thing here, reducing to lowest terms approach. All right, so 25 over 49 times 7 over 50. Reduce to lowest terms, and then you can easily work this out. Okay. Now, what about division of fractions? To divide fractions, you don't need LCD. Okay. What you do is that you keep the first fraction. So 20 over 33 divided by 5 over 11. We'll keep the first fraction, which is a 20 over 33. Keep that. That is this. All right. Then you change the division to multiplication. And then you take the reciprocal of this and multiply. Okay. So now becomes 11 over 5. Okay. Right. So this is division, how you approach division. Then you can reduce to lowest terms and multiply out. All right. So you have 20 over 33 times 11 over 5. Lowest terms, 5 into itself is 1, 5 into 20 is 4. 11 to itself is 1, 11 to 33 is 3. So we multiply 4 times 1, which is 4, and then 4 times 3, which is 3. Change to a mixed number, and then you have 1 1/3, right? 3 into 4, 1 whole number, 1 out of 3 left. So when you're dividing two fractions, if I have A over B divided by C over D, what we are saying is that keep the first fraction times reciprocal of the second fraction. Okay, that's what you do. Right? So if you have a mixed number, the same thing, you have to change to improper fraction first, like this one. 3 to 9 and 2/3 divided by 1/4. Okay. First, I have to change each of them to improper fraction. So 3 times 3 plus 2, that gives you 11 over the denominator, which is 3. Divided by, change this also to a mixed number. The mixed number here into an improper fraction. So 4 times 1, which is 4, plus 1. So that gives a 5 out of 4. All right, first step. Then you keep the first fraction, keep this, which is 11 over 3, times, change the division to multiplication, and then reciprocal of the second fraction, multiply that out. Okay. So there's nothing to reduce here, so you just have to multiply horizontally. 11 times 4, which is 44, 3 times 5, which is 15, and then change to a mixed number. All right. So those are the steps for working with addition of fractions, subtraction, division, and multiplication. I hope this helps you out in your review process. So we'll pause here and look out for my next video.